Koppel, host of the Time for Coffee podcast, where you get firsthand career advice into the jobs and industries that interest you the most. And before we start today's show, I have a quick favor to ask you. If you haven't already, I'd be incredibly grateful if you give us a rating and a review on iTunes. And if you're like me, you need to do it now because you'll forget later and because it's the best way to help others who may be in search of career advice to find this free resource. So press pause if you haven't done it and do it right now. I'll wait. Thanks so much and enjoy today's show. Hey there, Java junkies. Welcome back to another Espresso Shots episode of T4C. If you're interested in breaking into genomic research to unlock insights into health, development, and disease, then this is the episode for you, because my next guest is the chair of systems biology and a professor of systems biology at Harvard University, where she's worked since 2004. But before I introduce you to Dr. Galit Lahav, I want to make sure you've signed up for the Java Junkies Journal. That's Time for Coffee's newsletter that features career advice and inspiration based on insights that I've gleaned from interviewing hundreds of professionals in dozens of industries, and you won't likely find these insights anywhere else. Just head over to the Time for Coffee website at time4coffee.org, and the sign-up box is right there. Now, my mocha-loving, aspiring molecular geneticist, that's a mouthful, please grab your mug and take a chug of your favorite caffeinated brew, because it's time for another caffeinated career conversation. And my guest is Dr. Galit Lahav, the Novartis Professor of Systems Biology and the Chair of Systems Biology at Harvard University. Dr. Lahav has been recognized for her excellence in both teaching and research through awards and honors, including the Vilsack Prize for Creative Promise in Biomedical Science and in Excellence in Mentorship and in Mentoring, one of the most prestigious awards at Harvard University. I want to make sure I say that again. It was an Excellence in Mentoring Award, one of the most prestigious awards at Harvard. Through workshops and science communications trainings, Dr. Lahav has created many opportunities for junior faculty and postdocs to cultivate their own leadership skills. And she's currently spearheading an initiative to make Harvard a destination of choice for women in science through the expansion of both recruitment and support for women faculty. Dr. Lahav, Galit, welcome to Time for Coffee. Are you caffeinated and ready to go?
Thank you, Andrea. I'm so happy to be here. Yes, I am fully caffeinated.
Is coffee a part of your daily routine?
Absolutely. Important part of my mornings. Yes.
Oh my gosh. With all of the energy that you're expending with your brain, I can imagine you need to have rocket fuel.
Yes. Sometimes at the end of the day at night, I fantasize on the coffee next morning.
Me too. I'm telling you. So before we go any further, I was hoping you could explain to our young listeners what molecular genetics is, and in particular, systems biology, which is the department that you're currently chairing at Harvard.
Yes. Okay. Thank you. So the idea of systems biology is to try and understand biology or the human body, a disease from a systems perspective, meaning understanding that when we are trying to look at how our body works or how disease develop or how to treat disease, we need to take into consideration very complicated systems. We can't look at just one pathway or one gene, but we need to understand how things operate quantitatively. And in order to do that, we have to merge multiple disciplines. It's not just biology and medicine, but we need to look at principles coming from math and physics and computer science and engineering. And only when we understand how things operate collectively, quantitatively, we can predict when disease will emerge and we can control these development and also suggest treatments.
I love that because there is, as I'm sure you're well aware, a whole field within medicine that that is and has an integrative or functional approach to looking at the human body. So not in research, but in diagnostics and trying to get to the root cause of why people are developing different diseases, different dysfunctions within their body and their brain.
Exactly. That's exactly right.
So I know that you majored in biology at Technion, which is Israel's Institute of Technology. So let's frame the espresso shots around the field of biology research and what opportunities are out there for our young listeners who are interested in getting into this, especially into systems biology. So first espresso shot, what entry-level jobs are available to young people who want to get into biology research?
I think the best entry level is probably to go and be a research associate or a research assistant in a lab. Many undergrad, once they finish their college and want to figure out what they want to do, they come to labs and they spend about a year as a research assistant and they see if they like it, they taste it, they try it, they see if this is a lifestyle that can fit with their passion. And those who answer yes continue to go to a graduate level and then decide if they want to stay in academia or go to industry. But I would certainly start with experiencing research in the lab as a research assistant.
Fantastic. What is a useful hard and soft skill that you look for, Galit, in the young people that you hire in your lab?
Oh, that's such an excellent question. And I was shocked that it's quite difficult to answer because I was looking at all the excellent people that I mentored throughout these last 16, 17 years, and they're very different. Like there are different ways to be excellent in research. Some people are really good in seeing the big picture and integrating lots of things. Some pay attention to details. Some work as individuals just by themselves, and others love to work in team and bring lots of people together. And all of them did great. So I was wondering, what unites all of them? What is the one thing that they all had? And I think there are two things, actually. One is curiosity, like being really passionate about science, having this thrill when you discover something new, feeling that excitement. So being curious and passionate about discoveries. And two is determination. Like in research, it's more times things don't work than work. So being someone who pushed through the failures, that's extremely important.
So you need to have grit, almost like a single-mindedness about it. Because I would also imagine, and we're going to get into this in our main Time for Coffee interview. And by the way, listeners, check out show notes to see if Galit's main Time for Coffee interview has already dropped. You can check out show notes to see that. But one of the questions that I ask in the main interview is about failure. I'm guessing as a researcher, failure is like your middle name, right?
Absolutely. And I'm someone who became actually motivated by failure. When I fail, I do not break personally. I just get into the mode of, I'm going to show you that you are wrong. And I'm going to do so well that you'll regret you failed me. So it's a habit I developed to be persistent and push through.
Excellent. So the two qualities, curiosity and determination, for me are more on the soft skill side. What about hard skills, technical skills? What do you think are the most valuable for our young listeners to try to cultivate?
Again, it varies because the field is so interdisciplinary. People can come with a strong biological skills and then acquire the more theoretical mathematical skills when they come to us, or they come with strong analytical theoretical skills, math and physics, and then come to the lab and learn to pipette and run experiments. I've learned that, skills is something you can acquire in the environment that you're at. You don't have to come with those skills right from college, but the open mind to learn, to be a student, and to stay curious, these are, I think, really important.
Are you familiar with Dr. Carol Dweck?
I am not.
And her growth mindset. She wrote the book Mindset. Yes, you see,
Yes, I am actually, yeah.
Yes, so you need a growth mindset.
Exactly. Mm-hmm.
Okay, next espresso shot. What about someone's major? Is it a deciding factor to get into biology research that you've studied and that you've majored in biology?
Yeah. So, of course, if you know before you start studying that biology is your passion, then I think that would be a fantastic choice. Many times people are unsure and they go into other disciplines in science. But to enter systems biology, as I said, you can enter from many, many different directions. And we have students who completed a degree in chemistry, in engineering, in computer science, in statistics, in math, in physics. All of these and probably more. And because these are all part of systems biology, this integrates so many disciplines. And then our grad students, for example, they come and then we help identify where gaps exist in their knowledge and skills. And these are the skills they acquire during grad school. So of course, biology is a great way to enter, but there are many other ways as well.
Fantastic. So you mentioned graduate school. How important is it to have a graduate school degree? Less so for our young listeners who are in college right now. Maybe they've just graduated. But this would be in order to succeed, in order to be in the laboratory doing systems biology research. And if so, Galit, what degrees, what type of advanced degrees do you think are most important to try to get?
If the goal is to stay in academia or to pursue a research career in industry, I would say that it's quite important to do a graduate degree. And the reason is that while in college you study the materials and you acquire knowledge, it's really grad school that you learn to think independently. You learn to design experiments. You learn to interpret the data. You learn to come up with new questions. And I think the biggest thing is you learn to trust yourself that your questions are good and important and the ones in order to move the knowledge forward. So to do research, both again in academia and industry, I think graduate school is critical. If the goal is to be more of a service, like a lab technician or manager of a facility, then I think people can probably acquire these right from college. But I've seen most of the people that work around us, they come after their graduate degree.
So in terms of the type, do you think they need to get both the master's and then the PhD, or can a master's be enough?
A master's can be enough, again, depending where one wants to go afterwards. There's certainly a lot of people with masters who found excellent position in industry and acquire the experience in industry. If the goal is to be a professor in academia, then a PhD is a must.
Okay. And when you say industry, what type of industries are you thinking of?
Pharmaceutical companies, research and design. If one is interested in translational research, then working on clinical trials, all the biotech industry. As we know, as we are going through right now, we understand the importance of pharma and biotech, of course, in finding vaccine for the current virus we're all dealing with.
Yes, we should let our listeners know we're doing this interview right now at the end of January 2021. And thank goodness the vaccines have been created, but they're still not getting out to everyone. Galit, what type of life experiences do you think are most useful for someone starting out in this field? Life experiences being those we have outside the classroom.
Yes. So I'm going to go back to what we actually talked earlier. Research is really hard, and there are going to be more days that things don't work than they do. And those who've experienced failures and were able to find the determination to try again and again, these are the ones who are most likely to succeed. And I see it so many times. People who life was kind of just easy for them, they start experimenting research and they're shocked that suddenly things don't work and their hypothesis is wrong, and some of them just cannot recover from that. But those who already coped with lots of challenges in life, these are the ones who just get up right after they fail and try again.
Oh, so failing is a great life experience, or having adversity, dealing with adversity in your life.
Absolutely. And being resilient. Yes.
Resilience, so important. So, fun question. What is the best part for you of being in this field of systems biology?
There's so many things. I don't know if I can pick one, but I think probably for me, just working with awesome, talented people that I'm coming from really diverse backgrounds and coming with very different skills. And even though most of the time I'm their mentor. Many times I feel like as I'm the student, and I just keep learning from the people that I'm working with me. I'm just constantly learning. And I love working with people. It's beyond the thrill of scientific discovery, the relationship I make with people, the impact I have on their growth as their mentor, as a chair also enabling others and making an impact beyond my research. I just love that.
So you love the dual-hattedness of the roles that you have right now at Harvard.
Very, very much. Yes.
So as with any job, and certainly when you're, shall we say, in administration, there are aspects that are not going to be so much fun. So what is the part of your current job as a Novartis professor of systems biology and the chair of systems biology at Harvard that sucks the most?
That's easy. I would say it's the high demand of my time, and especially dealing with emails. I get a lot of emails every day. And usually at the end of my day, I look at my inbox and the many emails that I was not able to answer, and I need to make a choice, a decision. Am I going to spend another hour or two answering these emails or spending times with my family and my kids? And as you can imagine, most days I choose my kids. And so I end the day with a lot of emails that have not been answered. And I feel terrible because these are people reaching out to ask questions about our research or about the lab or about a paper and I want to be able to get back to all of them, and I just can't. And so I'm constantly feeling like I'm disappointing so many. So if anyone listening and ever emailed me and I didn't get back to them, I give a general apology that it's just becoming impossible with everything else that I need to devote my time to.
Oh, yeah. It's so hard to keep up. And especially you have 2 8th graders and you want to have the balance in your life. And I can imagine with the 2 hats you're already wearing, and then you've got your mom hat outside of that. It's a big challenge.
Yes.
So 3 final espresso shots. What is the best career advice you've ever gotten, Galit?
The best career advice is that there's no step in decision making that is final. And most of the decision we make can be reversible. I think many times we feel like, okay, I need to make this decision and this is going to dictate my entire life. And most times it's not the case. And for me, actually, when I got the offer from Harvard Medical School to join the faculty as a professor, I was quite terrified. And I was worried it's going to be too demanding. I won't be able to manage being a mom and a professor. And I almost said no. And then my postdoc mentor told me, give it a try. Just say yes. Try it for a few years. If you don't like it, if you suffer, if you see too much, just try something else. And there was something about just making it lighter that helped me realizing, okay, I'm not saying yes for the next 35 years. I'm saying yes for the next 3 to 5 years. And then I can reevaluate and decide if it's still right for me. Obviously, it was right. I'm still there. I love it. But I think I think a lot about this advice, and I give it to others when they are indifferent, need to make decisions about their career.
I love that advice. And in fact, it's what I've come to realize now, having done hundreds of interviews with professionals like you in all different kinds of industries, that the way that college students, and especially seniors, as they are looking to transition, if they're not going to go to grad school, from being a student into the workforce, is like this life-altering, capital C career. I'm now making a decision for the rest of my life.
Exactly.
Absolutely not. Absolutely not. Just try something. Try something. So I say, look at it as a small C career step, not a capital C career.
Absolutely. And you will learn something from every choice you make. And then you either decide to stay there and realize, oh, that's for me for the long term, or it's time to try something else.
In fact, I have to tell you, because this really is very much in line with what you're doing now. I wrote a post on LinkedIn recently in which I said that young people should approach their career not like a chef who every time is making a recipe, cooking a dish using that same recipe, but rather like a mad scientist who's in the lab lab experimenting and iterating and, trying a little something here or there.
I love that. Makes total sense to me.
All right. 2 final espresso shots. What movies, if any, or Netflix, Amazon, Hulu shows or books do you think accurately describe your profession?
That's a really hard one. The closest I can think of, not a movie, but a series, is Big Bang Theory. All right. It's a bunch of scientists working in academia. The issue is that it's far from accurate. And this show doesn't show any interactions with students, with postdocs. The one pretty woman in the show is not that smart. So I have some issues with this series. I just think that there's probably none. And it made me think that one of the TV networks need to make a series or a movie about scientists in academia. That's a great idea.
Really? And a reality show. What it is like to be working on some of these game-changing discoveries, like you are in your lab working around P53, which is a protein that can fight different tumors.
Exactly. Yes. And even movies about scientific discoveries, of course, they only show like the big moment that something was revealed, and they don't touch of the many, many, many years until one got to that point. So I wish there was more out there in the media about the life of scientists.
Well, maybe one of our listeners will be inspired to film one.
Hope so.
Final espresso shot. What would Java junkies be surprised to learn about your profession in systems biology, Galit?
Probably that there's no one template for how a Harvard professor is. When I became a Harvard professor, I cannot tell you how many people met me and said, "Oh my God, you don't look like a Harvard professor." And I hated that. I was like, what does this mean? Like, how does a Harvard professor should look? And so I think that the reality is that the Harvard professors or students are starting to look and be very different from the stereotype. We still have some way to go, but we are getting better. And nothing in how you look, where you come from, what your background is, what country you were born, your life experience, none of this should dictate whether you can or cannot, join a university as a professor.
Fantastic. Galit, I want to thank you so much for making time for coffee today with me and the T4C community. What you are doing, you and your colleagues in your lab, is so unbelievably important. I hope our listeners check out show notes to see if your main Time for Coffee interview has already dropped so they can learn more about it. Thank you so much.
Thank you so much. That was fun.
Thanks so much for listening to this latest episode of T4C. And if you're interested in learning more about my coaching services for confused college students and recent grads, feel free to check out the Time for Coffee website under the coaching tab at time4coffee.org or text me at 202-236-5712. That's 202-236-5712.